Right now, somewhere between Mars and the Sun, an object the size of Manhattan is doing something no one in human history has ever witnessed before. It's growing a tail. But this isn't just any comet tail, it's one that seems to break the rules of physics. Because this object, known as 3I, Atlas, didn't form here. It came from somewhere else, a traveler from another star system, and it's acting like it knows what it's doing. Astronomers first spotted it on July 1st, 2025, using the Atlas Survey Telescope in Chile, an automated system that scans the sky for anything moving where it shouldn't be. At first, it looked like a faint dot drifting among the background stars, but the orbit didn't make sense. It wasn't a closed ellipse around the Sunday. It was hyperbolic, the unmistakable signature of an interstellar visitor, something not bound by solar gravity. That alone made it the third confirmed interstellar object in human history. But then, in late August, something stranger happened. As 3I Atlas accelerated toward the inner solar system, telescopes began detecting a forward-facing plume material being ejected not behind the object, but ahead of it. A phenomenon known as an anti-tail. It was as if the comet were firing against its own direction of travel. Weeks later, the anti-tail vanished, replaced by a traditional, backward-streaming tail. A complete reversal. Astronomers called it the anti-tail-to-tail transition. Harvard astrophysicist Avi Loeb called it something else, a potential maneuver. If an interstellar spacecraft were entering a new solar system and needed to slow down, it would fire engines forward to brake, then reorient once the deceleration phase was complete. The anti-tail would mark braking, the tail, acceleration. Exactly what we just observed. To be clear, that's not proof. No one's claiming aliens. But multiple observatories have confirmed the transition, and the data is solid. What's happening between Mars and the Sun right now has never been documented before, a shift in behavior that defies conventional comet physics. Somewhere out there, a billion-year-old traveler is lighting up space, maybe a comet, maybe something more crossing the invisible line between what we understand and what we only dare to imagine. And that line is the event horizon of our curiosity. Once 3I Atlas was confirmed as an interstellar object, the world's telescopes turned toward it like a synchronized heartbeat. This wasn't a rumor or a blurred light curve on a researcher's laptop. This was the real thing. A solid object from beyond our solar system. Visible, trackable, measurable. The Nordic Optical Telescope in the Canary Islands was among the first to catch it in high resolution. Its September observations documented the moment the forward-facing plume, the so-called anti-tail, began to fade. Within days, a traditional cometary tail appeared behind the object. The transition was precise, almost mechanical. At the same time, Gemini South, perched high in the Chilean Andes, recorded images of 3I Atlas unlike anything we'd ever seen. A nucleus wrapped in a glowing coma, streaming dust and vapor, but with brightness fluctuations that didn't match the expected rotational rhythm of a natural comet. Then came a stroke of cosmic luck, the Mars. Reconnaissance orbiter crossed the same region of space just as 3I Atlas passed within 12 million miles of Mars, close enough for its onboard high-rise camera to capture the highest resolution images of an interstellar object in human history. Those photos were taken. They exist, but we haven't seen them. Not yet. NASA's planetary data servers, the same infrastructure that handles daily uploads from the Mars missions, went dark under a government shutdown. And so, the clearest images of an interstellar visitor ever captured by human technology sit locked in digital limbo, hidden from both scientists and the public. But science doesn't stop for politics. Even without the images, the data we already have is staggering. Spectroscopic analysis of 3I Atlas revealed a familiar chemical palette: water vapor, carbon dioxide, cyanide, common components of comets. But then came something utterly foreign, a nickel alloy unlike any seen in nature. Not a simple nickel-iron blend, as found in meteorites. This was an engineered mixture, the kind of composite humans forge for strength and resistance, the kind used in spacecraft hulls and turbine blades. Its spectral signature was clean, unambiguous, and impossible to dismiss. Astrophysicists scrambled for explanations. Could extreme temperatures or pressures inside some alien star system forge such a compound naturally? Could billions of years of cosmic radiation transmute elements into that configuration? Maybe, but no model yet explains it. And then, another anomaly. Activity at impossible distances. At 1.4 astronomical units, roughly 1.5 times the Earth-Sun distance, comets are usually dormant. Water ice doesn't sublimate aggressively that far out. It takes the sun's closer heat to awaken it. But 3I, Atlas has been venting material at 40 kilograms per second, the equivalent of a high-pressure water cannon, active for months. And the composition driving that activity is strange. Where typical comets are dominated by water ice, this one shows an 8-to-1 ratio of carbon dioxide to water. That's unheard of. It means CO2, not water, is the primary volatile driving activity, even in the cold. The result, 3I, Atlas, became visibly active while still deep in space, far earlier than any model predicted. That alone would make it the most interesting comet ever studied. But the anomalies kept coming. Spectral data showed high concentrations of cyanide, far more than expected. Cyanide chemistry plays a role in the origins of life. It can also serve as a reactive compound in propulsion systems. Either interpretation raises eyebrows. If this is natural, it's a time capsule from the chemical infancy of the galaxy. If it's not, it's something else entirely. To manage the chaos of curiosity, the International Asteroid Warning Network, IAWN, stepped in. Normally, this organization exists to monitor potential Earth impactors, the rocks we worry about. But 3I, Atlas, isn't a threat. It's an opportunity. Their official bulletin read, "While it poses no danger, Comet 3I, Atlas, presents a valuable opportunity for the global observing community due to its high visibility and scientific interest." That's the careful language of scientists trying not to sound excited. Behind the scenes, every major observatory from Hawaii to the Canary Islands to Chile adjusted its schedule to track it. Space-based telescopes recalibrated. Even NASA's Solar and Heliospheric Observatory, SOHO, began preparing to capture the object's approach to the Sunday. It's rare to see this kind of mobilization outside an asteroid threat. The only thing more unifying than fear is wonder. And wonder is exactly what 3I, Atlas, is producing. Yet for all the data, the big question lingers. Why is it doing what it's doing? Comet physics is messy. Outgassing, rotation, sunlight, and gravity interact in unpredictable ways. But even in that chaos, certain patterns hold. And 3I, Atlas isn't following them. Take the anti-tail again. In rare cases, perspective can make a normal tail appear forward-pointing due to the alignment of dust particles and sunlight and optical illusion. But this wasn't an illusion. It persisted for weeks, across multiple telescopes and hemispheres. The plume contained not just dust, but that same strange nickel alloy. When the object's trajectory shifted and the tail flipped, the alloy's spectral signature faded, as though the source of the material had changed. That's what keeps scientists up at night. Not the alien theory itself, but the data that fits it better than the natural ones. Avi Loeb, ever the provocateur, published a short paper noting the coincidence. He didn't claim 3I, Atlas, was a spacecraft. He said something far subtler and far more dangerous to scientific comfort. We cannot rule out the possibility that it is. Those 11 words sent shockwaves through the astronomical community. Not because they proved anything, but because they reopened a door most scientists prefer to keep closed. The idea that extraterrestrial technology might already be within reach of our instruments, not in the form of radio signals, but as physical objects silently passing through our sky. Still, science demands restraint. Extraordinary claims require extraordinary evidence, and so far, we have anomalies, not answers. But anomalies are where discovery begins. As October unfolds, 3I, Atlas barrels, closer to the sun, glowing brighter each day. The forward-facing plume has long vanished. The tail now stretches millions of kilometers, glinting in solar wind. In 4 days, it will reach perihelion, its closest approach. And what happens then could rewrite everything. Because as it moves inward, the heat will intensify. Outgassing will surge. Material will erupt. The comet will either survive, revealing resilience that defies its supposed fragility, or it will disintegrate. If it survives, we'll have to ask why. How could something billions of years old forged in the deep cold of interstellar space, endure the furnace of a star and emerge intact. If it breaks apart, we'll gain the data we need, pieces of a relic older than our sun, dissected by the heat of curiosity. Either way, we win knowledge.
If it breaks
But we
apart,
also edge
we get
closer
the
to an
data.
unsettling realization.
Pieces of a
We're not
relic.
just observing a comet. We're watching an object from another world, acting in ways we can't yet explain, holding secrets older than our civilization, and moving perhaps deliberately through our cosmic neighborhood. That's the essence of this investigation. Not to prove a theory, but to admit that the universe still surprises us. To confront the limits of our models.
Observing a comet.
To look into the unknown and whisper, we don't know yet. And that, in science, is the most honest answer of all. To truly understand 3I, Atlas, you have to zoom out, way out, until the entire solar system looks like a small stage on which a few cosmic wanderers occasionally drift through and vanish. Because this isn't the first time something from beyond has come visiting. It's just the first time we were ready to see it happen. The visitors before back. In 2017, humanity got its first glimpse of an interstellar traveler. Astronomers at the Pan-STARRS Observatory in Hawaii spotted a faint, elongated object racing across the sky. It was named Oumuamua, Hawaiian for a messenger from afar, arriving first. It came from nowhere, reflected sunlight strangely, and then, as it left the solar system, it accelerated. No jets, no outgassing, just motion that defied gravity alone. Scientists scrambled to explain it. Was it a hydrogen iceberg? A pancake-shaped dust fractal? A shard of a shattered planet? Every model required physics gymnastics. And when Harvard astrophysicist Avi Loeb proposed it could be artificial, perhaps a thin, reflective sail propelled by sunlight, he was dismissed by many and celebrated by few. But one thing was certain, the mystery was real, and it changed the rules. 2 years later came 2I, Borisov, discovered by an amateur astronomer in Crimea. It was everything Oumuamua wasn't familiar. Cometary, chemical, a tail, a coma, predictable outgassing, comfortingly normal. Scientists breathed a sigh of relief. Maybe Oumuamua was the odd one out, a cosmic fluke. Then, in 2025, came 3I, Atlas. And suddenly, the comfort vanished again. It had the body of a comet, the chemistry of something alien, and behavior that didn't fit any playbook. Where Oumuamua was silent, 3I, Atlas is loud, spewing gas, dust, and light, but in all the wrong ways. 3 interstellar objects in just 8 years. That alone is extraordinary. For most of human history, we didn't even know other galaxies existed. 100 years ago, we couldn't have imagined objects crossing the void between stars. Now we've seen 3, each one completely different. And statistically, that's shocking. If 3 have passed close enough to detect in less than a decade, it implies there are millions of them wandering the galaxy, a steady rain of cosmic debris and possible artifacts moving through the interstellar dark. We were blind before. Now our eyes are finally open. A galaxy of drifters, our Milky Way isn't static. Stars orbit its center like bees around a hive, each dragging along a swarm of planets, asteroids, and icy bodies.
Older than our sun.
Over billions of years, gravitational tides eject some of those bodies, comets and fragments, flung into eternal exile, drifting through the interstellar gulf. Most are frozen, silent, invisible. But occasionally, one crosses our path, and every time that happens, it carries with it the chemistry, the history, and the story of a different star system. 3I, Atlas, for instance, appears to have formed 7 to 10 billion years ago, long before our sun existed. Its isotopic ratios hint that it was born in a region where carbon dioxide was far more abundant than water, perhaps near a dim, cold star, or even in a molecular cloud, one of the cold, dense regions where stars themselves are born. Think about that. You're looking at an object older than Earth, older than our sun, older even than most of the stars you see in the night sky. A relic from a time when the galaxy was young, when the Milky Way's arms were still thick with starbirth and chaos. For billions of years, 3I Atlas has drifted through interstellar space untouched, unchanged, frozen, near absolute zero. No erosion, no weather, no decay, just endless night, until now. Until it wandered into the light of another star, ours. When that happened, it began to wake up. Its frozen gases started to sublimate, forming jets and plumes. In essence, it came back to life after billions of years asleep, a time capsule stirring for the first time since before life existed on Earth. It's poetic and unnerving, because the longer we observe it, the less it behaves like a fossil, and the more it behaves like something alive, comet or craft. For scientists, this duality is maddening. Every data point can be explained two ways, one natural, one artificial. The antitail could be jets from unusual rotation or controlled thrust. The nickel alloy could be exotic crystallization or engineered material. The cyanide levels could be primordial chemistry or a propellant residue. The stable structure after billions of years could be dormant preservation or deliberate design. Each explanation seems plausible until you line them all up. Then the coincidences start to stack. That's what makes 3I Atlas so unsettling. It fits both models, comet and craft, almost too perfectly. And in that narrow overlap between science and speculation lies the entire mystery of our age, a universe filled with anomalies. The truth is, space is full of weirdness. We've seen comets split apart for no reason. Asteroids change brightness overnight. Even dust clouds mimic solid objects under certain conditions. Nature can mimic intelligence, and intelligence can hide in nature. If a civilization wanted to send probes across the galaxy, how would they do it? They wouldn't build gleaming ships with engines blazing. They'd send something quiet, durable, self-sufficient, something that could drift for billions of years, disguised as a natural object. Something that could harvest sunlight, study planets, and then move on. It's not an absurd thought, it's engineering logic scaled to the cosmos. A message-in-a-bottle civilization could scatter such objects across the galaxy, trusting physics to do the delivery. They might never even know where each one ended up. And that's where 3I Atlas becomes more than a comet. It becomes a mirror, because if it is artificial, it tells us something profound. That intelligence doesn't just arise, it endures. That curiosity, somewhere out there, was as strong as ours. Strong enough to reach across the stars and leave something behind. The great pattern. The more we find, the more a pattern begins to emerge. Oumuamua, silent and smooth, as if it were a fragment of technology. Borisov, chaotic and natural, the control specimen. 3I, Atlas, the hybrid, a bridge between both. 3 samples, 3 different outcomes. That's not coincidence, that's diversity. And diversity means numbers. For every one we see, countless others must pass unseen, too dim, too distant, too unremarkable to notice. Statistically, the galaxy must be filled with them, a continuous migration of relics, natural and possibly engineered, crisscrossing the interstellar void. We used to think of our solar system as isolated, a neat bubble in a quiet corner of space. Now we know it's porous. Objects come and go. Messengers arrive and depart. Some may just be frozen memories of dead stars. Others could be the last surviving traces of civilizations long gone. And in a way, it doesn't matter which. Because both possibilities are equally humbling. Either the galaxy is teeming with ancient natural relics, fossils of cosmic evolution, or it's seeded with technology so old it predates our species. In both cases, we are the latecomers, the ones still learning to listen. Perspective shift. When astronomers trace 3I, Atlas backward through the sky, its path leads toward the constellation Ursa Major, the Great Bear. That's where it came from. Not from a specific star, but from a direction in galactic space we can map precisely. Its velocity relative to the Sun, 210,000 kilometers per hour. Fast, but not unreasonable for an interstellar drift. Its orbit tells us it's not bound to the Sunday. Once it rounds our star, it will leave again, heading out toward Lyra, never to return. A one-time visitor, like a cosmic traveler brushing past our doorstep and continuing into the dark. That's the context. A journey that began billions of years ago, now intersecting with ours for a few brief months. A fleeting overlap between two timelines, humanity's rise and a relic's passing. When you step back far enough, the story of 3I Atlas isn't about aliens or comets. It's about time, about endurance, about the fact that something made of dust and ice can survive the death of its star, wander the galaxy for eons, and still burn bright when it meets a new sun. That's the power of deep context. It reminds us that everything we see is a survivor, and that includes us. Right now, 3I, Atlas, is racing inward toward the sun, faster, hotter, and brighter with every passing hour. By the time it reaches perihelion, just 130 million miles from the solar surface, it will be enduring a blast of radiation equal to tens of billions of watts, striking every square meter of its surface.
It's revelation.
For a natural comet, that's torture. For a relic from another star, it's revelation. The countdown. The world's telescopes are already in position. Ground observatories across the Americas, Europe, and Asia have synchronized their schedules. NASA's SOHO and Solar Orbiter spacecraft are ready to track it through the blinding glare of the Sunday. For the first time in history, humanity will watch an interstellar object dive into and out of solar proximity in real time. The date is October 29th. In 4 days, 3I, Atlas, will cross the threshold, the point of no return. For 2 weeks after that, we'll lose sight of it entirely. It will slip behind the sun, hidden from every telescope on Earth. During that blackout, anything could happen. It could fragment under the stress of solar heating. It could brighten dramatically as sublimation intensifies. It could reappear as a faint ghost or not at all. And the possibility that haunts everyone is that it might change course. Because trajectory is the ultimate truth in space. Gravity is predictable. Light pressure is calculable. Outgassing from comets can be modeled. But if 3I, Atlas, emerges moving in a way that no natural forces can explain faster, slower, or simply different, then the conversation changes forever. The models and the unknowns. Astrodynamicists have run thousands of simulations. They've accounted for every gravitational influence, the Sun, Mars, even Jupiter's faint tug from hundreds of millions of miles away. They've modeled the effect of solar radiation pressure, the tiny push of photons on dust and gas, and even the drag of outgassing jets venting from the surface. Everything fits for now. But small deviations, just a few meters per second, could grow into enormous positional errors after the Sunday. A deviation that can't be accounted for means one thing: propulsion. And propulsion means control. It's the kind of data that could turn an obscure scientific anomaly into the most important discovery in human history. That's why observatories from Chile to Hawaii to the Canary Islands are standing by. Every major telescope will be aimed at the dawn sky in early November, waiting for the reappearance. What they'll find, no one can predict. The missing images. Meanwhile, the high-rise images from Mars remain unreleased. Locked behind the wall of bureaucracy, they've become almost mythical, the highest resolution photos ever captured of an interstellar object, yet unseen. At 12 million miles, the Mars orbiter could have resolved details as small as a few dozen meters. That's not enough to read surface inscriptions or spot find structure, but enough to tell us if the shape is irregular and lumpy, or smooth and geometric. If 3I Atlas looks like a comet, the story cools. If it looks engineered, symmetrical, uniform, or angular, the story explodes. Scientists know this, and the frustration is palpable. One of the most profound datasets in modern astronomy is sitting idle because of administrative paralysis. A reminder that even in the age of interstellar discovery, humanity's greatest obstacle is still itself, the object in motion. From the data we do have, 3I, Atlas, is large, roughly 2 to 6 kilometers across, weighing an estimated 30 billion tons. That's massive enough that internal composition matters. If it's porous, like typical comets, it should crumble under solar heating. If it's dense or metallic, it could survive barely scorched, re-emerging intact. Already, signs point to resilience. Despite weeks of solar exposure, there's no evidence of fragmentation. Brightness variations suggest not chaos, but stability, a controlled rotation, almost rhythmic. That's unusual for something so ancient. Comets typically tumble irregularly after billions of years of collisions and spin-up effects. 3I, Atlas, by contrast, seems balanced. Could that be coincidence? Possibly. But it's another anomaly on a growing list, the chemistry of the impossible. The composition data continues to baffle. That nickel alloy with its engineered ratios of nickel, chromium, and trace titanium doesn't belong in a comet. On Earth, Such alloys are created for extreme environments: aerospace, reactors, heat shields. They resist melting, erosion, and radiation. In short, they're designed to survive the impossible. And then there's the cyanide: concentrated, reactive, volatile. Under certain conditions, cyanide compounds can serve as chemical propellants, releasing vast energy when decomposed. If that's what we're seeing, if the anti-tail that appeared months ago was the residue of such a reaction, it might not have been outgassing at all. It might have been exhaust. That thought alone has forced scientists into uncomfortable territory. Because if it's true, then 3I, Atlas, isn't just moving through our solar system, it's operating in it.
Is it a glitch?
Still, there's a difference between possibility and proof.
Is it real?
For every scientist eager to test the artificial hypothesis, there are dozens demanding patience. They remind us that space is full of surprises, that our models of cometary behavior are incomplete, that what looks engineered might simply be unknown physics. They're not wrong. But as one astrophysicist put it, every discovery looks like magic until you understand the math. The problem is, we don't have the math yet. The wait October 29th arrives. 3I, Atlas, dives toward the sun, the tail lengthening into a silver filament millions of kilometers long. From Earth, it's invisible against the glare. From orbit, the solar telescopes catch a brief, blinding flicker, a streak of light where the comet crosses the corona. And then, nothing. For days, silence. The object slips behind the sun, hidden from view. Radio astronomers monitor the region for any signals, any electromagnetic anomalies, but detect none. All we can do is wait. 2 weeks stretch like an eternity. Humanity, collectively, holds its breath. Every scientist, every skywatcher, every person who's followed this story is watching the same region of sky, waiting for something to reappear. The return early November. Pre-dawn skies over the southern hemisphere. Telescopes across Chile and South Africa begin scanning. And then there it is. A faint speck, right where the models predicted. Or maybe not exactly. It's there, but something's off. Slightly displaced from its expected position. Within error margins barely, but enough to raise eyebrows. Is it a measurement glitch, a calibration error, or the first sign of a change in velocity? We won't know for days, maybe weeks. But one thing is clear. 3I, Atlas has survived. No visible fragmentation, no catastrophic breakup. It went through the inferno and came out intact, its brightness steady, its shape consistent. For an object billions of years old, forged in another star's long extinct system, that's astonishing. Comets aren't supposed to do that. They're fragile, brittle, ephemeral. 3I. Atlas seems built to last. The implications. If it's natural, that resilience tells us something remarkable, that interstellar comets are hardier than we ever imagined. If it's not, it tells us something even more profound. Because to build something that can survive a solar pass after billions of years adrift would require technology far beyond our own, not just in power, but in purpose. It would mean someone, somewhere, once built things to endure forever. And as scientists begin to analyze the post-perihelion data, a pattern emerges. The brightness curve isn't just stable, it's rhythmic. Subtle variations, repeating at regular intervals, as if the object is rotating or signaling.
This can't be right.
Coincidence?
Run the analysis
Probably.
again.
But the very fact that serious
We've run it
scientists
5
are using the
times,
word
Doctor.
signal at
The
all
results are
marks a
consistent.
shift.
The
10 years
displacement
ago,
data.
such
The
talk
gap
would
is
have been
small,
career
but it's
suicide.
real. The
Now,
deviation
it's
is
just
real.
another hypothesis in the
Data
stack.
deleted.
Because
Error.
that's what
The Milky
3I,
Way.
Atlas has done. It's expanded the Overton window of the possible. It's made the unimaginable thinkable. For now, the debate continues: comet or craft, physics or purpose. But regardless of which side you're on, everyone agrees on one thing. We've never seen anything like this before. And whatever happens next, it's changing how we look at the universe and how the universe might be looking back. When 3I, Atlas, re-emerged from behind the sun, alive and intact, something subtle changed not just in astronomy, but in us. Because whether we admit it or not, we were all hoping for a sign. We wanted it to break the rules. We wanted it to prove that the universe still holds mysteries that don't fit in our equations. And it did. Just not in the way we expected. What we know. Here's what we know for certain. 3I, Atlas is real. It's interstellar, a confirmed visitor from beyond our solar system. It's massive, ancient, and active. It's made of things we understand and one alloy we don't. It defied the expected timeline for outgassing. It survived a close encounter with the sun that should have destroyed it. And it left us with more questions than answers. That's the scientific summary. But there's another, quieter truth underneath. 3I, Atlas, has reminded us of our place and of our potential. Because in watching it, we weren't just studying an object. We were seeing ourselves reflected back through time, a young species staring at something impossibly old, trying to decipher a language written in light and motion. First contact, reimagined.
Remember?
For decades, science fiction imagined first contact as a headline. A ship in orbit, a transmission from the stars, a conversation across space and time. But what if it's quieter than that? What if contact doesn't come as a greeting, but as a discovery? Not a hello, but a remember. If 3I, Atlas, is artificial, if it's a fragment of technology launched billions of years ago, then we may already be living through first contact. Not the cinematic kind, the cosmic kind. The version that spans epochs instead of moments. A conversation not between civilizations, but between their echoes. A civilization that built something to endure for billions of years was, at its core, motivated by the same thing we are, the desire to reach beyond itself, to be remembered, to leave a mark, and that's what connects us. If we ever build something to sail between stars, to drift for eons through the void, it won't be to conquer. It'll be to be known. And in that sense, 3I, Atlas, might be the mirror of our own future, a story we haven't written yet, reflected back at us from the past. The meaning of the unknown. Of course, the rational mind resists this. It wants certainty.
The evolution of
It wants
seeing.
the press release.
Now we have
Confirmed.
eyes.
Alien spacecraft detected. But science rarely gives us such neat endings.
Who else?
What it gives us
is
instead
out there?
are questions and the discipline to sit with them. 3. I, Atlas, is still, most likely, a natural object behaving in unexpected ways. That's the conservative view, and it's probably right. But in a sense, that makes it even more extraordinary. Because if a comet, a lump of rock and ice forged before our sun was born, can drift across the galaxy for 10 billion years and still surprise the creatures of one small planet, then that's miracle enough. A speck of its dust, every molecule of carbon dioxide it exhales, is a fragment of a world long vanished, a ghost of creation itself. We're watching the past, alive again, in the light of our present, our place in the story. When people ask what it means, the scientists give technical answers. It means interstellar objects are more common than we thought. It means our solar system is not isolated. It means the galaxy is dynamic, alive, filled with travelers. But beyond the numbers, there's something deeper. It means that we're part of the story now. For billions of years, these objects passed unnoticed. Now we have the eyes to see them, the instruments to study them, the curiosity to care. 50 years ago, we couldn't have detected it. 100 years ago, we didn't even know such things existed. Now, we can track them across the void, measure their chemistry, and ask the oldest question in the universe. Who else is out there? Maybe no one. Maybe everyone. Maybe we're just the latest to look up and wonder. The final reflection, somewhere between Mars and the sun, that Manhattan-sized traveler is fading now, moving back into the dark, its tail dissipating into the solar wind. Soon it will be gone, a faint trace of data, a curve on a graph, a whisper in the archives of astronomy. But for a moment, it shared our sky. For a moment, it turned its face toward our star and showed us that even the coldest relics can burn again. And that's the real story, not that we might have seen alien technology, but that we're capable of seeing anything at all. That a species born on a single world can build instruments, cooperation, and curiosity strong enough to watch a visitor from another star and to feel awe instead of fear. We're still new at this. We're still learning how to look up. But 3I, Atlas, is proof that we're paying attention, that we're listening, that somewhere between science and wonder, we're still humble enough to be amazed. Maybe it's a comet. Maybe it's a craft. Either way, it's a message, one written not in words, but in endurance.
Go away.
A reminder that curiosity is the closest thing to immortality we have. So, for now, we wait, we measure, we wonder, and we whisper our gratitude into the dark, hoping the universe hears it, for the visitor between the stars has already moved on. And we, the watchers, are left standing in its fading light.